Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be on page 295 and we're going to be talking about determinants. That's in lesson 6.4, page 295. What is a determinant? Well, it really is kind of just the way the word sounds. It determines something. What does that mean? Well, it kind of gives you an insight about something. It kind of makes something happen or makes something not happen. It determines what's going to happen. Well, if you look down here at the screen, it says a number that can be used to find different properties of the matrix or system of equations. What does that mean? Well, here's what it means. When you find the determinant, and what we're going to show you how to do that in just a second, you will know certain things about the matrix. For instance, one thing that you'll know is you will know if it has an inverse. Okay? Well, what does that mean? Well, I'm going to tell you in a couple lessons, so you got to keep watching the videos to find out what the inverse is. Another thing that it does is it tells you how many solutions the system, or it tells you not how many, but it tells you if the system of equations has a solution or has no solution. So remember when we were solving those before and we'd get parallel lines and it would be no solution? Well, you could find the determinant, and the determinant will tell you if it has a solution or if it does not have a solution. So the determinant is useful and it tells us different things about it. So how do we find the determinant? What does it look like? All that good stuff. Well, let's keep looking down on the page. We have two different forms. So we have the matrix, and I'm going to write the word form with this. So the matrix form and the determinant form. This is not the determinant, okay? This is just a format that is called the determinant form, okay? If you'll notice, there's some differences with the determinant form and with the matrix form. All right, what are some differences? Well, here's a difference. That thing right there is like a bracket on the matrix. Look at it on the determinant form. It's just a straight line. It almost looks like an absolute value. The other thing that is different is the A out here is just A equals, and here it looks like absolute value of capital letter A equals. Now, that doesn't mean absolute value. But it just means determinant. So when you see these absolute value sticks right here, now they're not around a number. We're not talking about numbers. We're not talking about absolute values. We are talking about determinate form. So make sure you kind of separate those two things in your mind. All right. The two biggest concepts of this chapter, this lesson right here, are the diagonal and the antidiagonal. If you can master these and how to figure out these, what they are, how to use them, then you're going to be just fine in this lesson. What's the diagonal? Well, we talked about that a few lessons ago, if you remember. The diagonal starts from the upper left to the lower right. And I'm drawing an arrow because it's going that direction, okay? It starts at the upper left and goes to the lower right. Now, what's the antidiagonal? And this is important. Look at what direction it starts. It starts at the bottom left and goes to the upper right. It starts bottom left and goes to upper right. That is very important with the antidiagonal. Don't start it at the 2 and go to the 3. So don't start in upper right and go lower left. Okay, and that'll come into play a little bit later. It's not a big deal right at this moment, but you'll need to know that for later. All right, so diagonal, antidiagonal. And you know, we have diagonals and antidiagonals here as well. Just because it's not in the determinant form doesn't mean that they're not still there. They are. So we can use that in the matrix form and in the determinant form, either one. All right, how do we find the determinant for a 2 by 2? How would we do that? Well, here's the steps, or really just one step. It's just one little formula that's used. Subtract the product of the antidiagonal from the product of the diagonal. Okay, so what does that look like? Well, let's take these off of here real quick, and let's look at this. So what's the diagonal? Let's start with the diagonal. That's this right here. Okay, so we want the product of the diagonal. That's 1 times 4. What does that equal? 4. So the product of the diagonal is 4. What's the product of the antidiagonal? okay? And that would be this one right here, going from 3 up to 2. 3 times 2 equals 6, okay? So now what does our little formula say? Subtract the product of the antediagonal from, so what's the product of the antediagonal? 6. We're going to subtract that from 4. So 4 minus 6 equals negative 2. In this case, our determinant is going to be 2. So we could put determinant equals negative 2. Okay, that was a negative 2. What does that tell us? Well, let's keep going. This is on the top of page 296. Top of page 296. It says, if the determinant is 0, then the system has no solution. Okay, so that would mean that our lines are parallel. If it comes out to 0, our lines are parallel and we have no solution. Was our determinant 0? No, it was negative 2. So, do we have a solution? Yes, we do. Ours would have a solution. Okay, let's do one more example of that before we go on to the next example. 1, 4, negative 1, 3. All right, so I'll use the yellow and the pink again. So this is going to be our diagonal. So that's 1 times 3 equals 3. And then our antidiagonal is here. And so that's 4 times negative 1, and that equals negative 4. Now what do? It says that we subtract the antidiagonal from the diagonal. So the diagonal was 3 minus 4. What's our rules of addition and subtraction in algebra? Well, if we're subtracting, we change the sign of the second and add. 3 plus 4 equals 7. Our antidiagonal is 7. So, or excuse me, our determinant is 7. I keep saying antidiagonal. Our determinant is 7. What does that mean? If the determinant is anything other than 0, if it's a number, positive or negative, then that means that we do have a solution. The other thing that it means is that it does have an inverse, okay? So an inverse. What is an inverse? Well, we know what an inverse is. Like, what's the inverse of 2? The inverse of 2 equals 1/2, okay? So it's a little bit different. The way it plays out in a matrix is a little bit different, but that's kind of the concept right there. And we will, in a couple lessons, we'll be going through and talking about the inverse. But for right now, you just need to know, if it's 0, it doesn't have an inverse. If it's 0, it doesn't have a solution. Or if it's 0, it could also have indefinite solutions. The lines could be coincident and be right on top of each other. But in this case, it's a 0, or it's a 7, so it does have an inverse and it does have solutions. All right, let's look at this one. Now we're going to step up our game just a little bit. Those 2 by 2s were just a little bit too easy for us. So let's do a 3 by 3. All right, 3 rows and 3 columns. Look at page number 297. That's where you're going to find this one, page 297. Now, the way that this solves out is exactly the same. So let's go ahead and write this using discriminant form. So we'll kind of put this like almost like an absolute value looking thing. Now, if you notice, if we try to find the diagonal of this, we have a diagonal, and we have another diagonal, and we have another diagonal, but they're not really like complete diagonals. They're like 2 of the 3. We only have one that has 3 numbers in it, okay? So let me show you what we do with this. Here's what we do. We take these 2 columns right here, and we reproduce them over here. We just rewrite them. All right, so we're going to write, I'll write it in green, 4, 4, 2, 7, negative 3, 0. We're just going to rewrite them. Now watch what that allows us to do. We got 3 in that column, in that diagonal, 3 in that diagonal, and 3 in that diagonal. Okay? And then look, our antidiagonals. We have 1 antidiagonal, 2 antidiagonals, 3 antidiagonals. Okay? And so what it does is it basically completes um, the discriminant matrix for us and allows us to find the discriminant. All right, so let's do it. Let's start with this, and we're just going to do we're just going to follow our steps. Well, what does our step say? Well, look at the top of that page where it says discriminant of a 3 by 3 matrix. That's on 297 again if you're not paying attention. And it says, rewrite the columns. Oh, we already did that. Number 2, find the sum of the positive diagonals, the blues. So we're going to, in ours, well, I'll do it blue. No, they've got green. They use blue and green. I'm going to stay with the yellow and the pink, okay? And so what we do is we want to find the first one, okay? So what's the first one? Negative 3 and 5. 4 times negative 3 times 5. And we're going to multiply that up. Well, what do we get when we multiply that up? Okay? 4 times 3, 12, 60. Negative 60. Okay? And then we're going to do the next one. So now we have 7 times negative 2 times 2, and that equals negative 28. Negative 28. And then we've got this one. And whenever there's a 0, that's great because all of a sudden it's just 0. That just really quickly solves that one for us because anything times 0 is 0. Okay? And so now what we want to do is we want to take these answers and add them up. All right? So what is that going to give us? Negative 88? Negative 88. All right, so I'll put that up here, negative 88. And then we'll go ahead and get rid of all this stuff. All right, so that is our diagonals. And now we have to do our antidiagonals. All right, so we'll do these ones in pink. And these are the ones that start here and go up here. So I have a 2 times negative 3 times negative 1. What is 2 times negative 3 times negative 1? That equals a positive 6. Positive 6. And then we do it again. 0 is in that one, so that one just automatically equals 0. And then we will do it right here. So we have a 5 times a 4 times a 7. And that equals, let's see, 5 times 4, 20. 20 times 7 would be 140. So 140, then we add those up and we get 146. 146. So I'll put that up here, 146. And we'll get rid of this again. Now we kind of go back to what we did before. What did we do before once we got our diagonal and our antidiagonal? Well, we subtracted them. We subtracted the antidiagonal from the diagonal. So we go up here and we'd actually subtract this minus 146. And let's see, what do we get? When you're subtracting in algebra, what do? You change the sign of the second and add. So we're just going to add those together. And that gives us a negative, let's see, 4, 3, and 2. Negative 243 is our answer. So our discriminant in this one is negative 243, or 234, sorry, negative 234. And what do we know about that? Well, one thing that we know about that is that it does have an inverse, okay, and that it does have solutions. So those are the two things that we learned about that. But basically in this lesson, the two things that I want you to be able to do is find the diagonals and the antidiagonals. And then secondly, I want you to be able to find the discriminant. How do you find that? By taking the product of the antidiagonals and subtracting them from the product of the diagonals. Okay? And you do that, boom, you got your answer, and you know some things about it. There's actually a lot more things that you know about it, but for right now, we'll just stick with those two things that we know about it. Okay? Well, that's all I've got for you. I hope you learned something there. If you didn't, make sure to rewind that, watch it again so that you can know what's going on for these quizzes, tests, homework assignments that you have coming up in your class. Okay? All right, we'll see you later. Bye-bye.